Hello everybody, my name is Farbod Ahmadian. I'm a second year C student and that's it. I should mention that I don't have any additional microphone, so I'm using my phone as my microphone. I hope this doesn't make any noises back there. And also I should mention that English is not my first language. That's it. Let's head back to our problem. Recently, I saw a problem in Stack Overflow, which it says, how can we find duplicated data in an array? Or let's say vector, because we are going to use C++. So that's the problem. How can we find the duplicated data in an array? Let me show you the algorithm. So assume that we have some data, for example, 1, 2, 2, 3, 1, 4, 2, for example. How can we find the duplicated data there? The worst approach that we can go is to compare each element by element. For example, I should compare this with this, then I should compare this with this, again, should compare this with that, and so on. And next, compare this with this, compare this with this, compare this with that, and so on. And again, I should compare this with this element with this element. It's the worst approach that we can go. It has time complexity of n to the power of 2, which is the worst, one of the worst time complexities that we have. So we are not going to use this one. So what can we do? Think for a second. What will happen if we sort this data? It's getting better, yes? Let's sort it. We have a 1, we have another 1, we have 2, we have 2. This is the first approach that we are going. I have another approach too. Just please bear with me. 1, 1, 2, 2, 2, and 3, and 4. So now, please don't implement this approach that I said earlier. You have to use 2 nested for loops and compare each element with the next one. So please don't do that. It's the worst approach that we can go. And now in here, I have to just compare each element with the next one. Compare this with this, compare this with this, compare this with this, and so on. It's look better, yes? Here, the complexity is our sorting algorithm. Because I'm going to use C++, the sorting algorithm is going to be intrusort, which has time complexity of O(n) log n, which is called linearithmic. O(n) is called linear. That's better. O log n is called logarithmic. And combination of these two is linearithmic. It's just a name, and it's better than O to the power of O(n) to the power of 2. If you are using Python or Java, I think both they use teamsort, which is also n log n. It's again linearithmic, but it's obvious that implementing this algorithm in C++ is going to be much faster. And I should say that we are going to have a performance measurement using our Linux commands. Please bear with me and let's start our job. Okay. So I want my input-output stream. I need vectors. For those who are not familiar with C++, I should mention that vectors are somehow arrays. and I want, that's it. We will include everything as we want. This is my main function. From std namespace, I want a vector of integers. It's like to say I have an array of integers. It's not important. And let's say data, and let's say 1, 1, 2, 4, 3, 1, 5, 3, 2, 6, and 10, for example. Okay, and I wanted to store my duplicated data in a set. Okay, set is a kind of collection that do not allow duplications. So I want to just have the duplicated number in my data vector to just happen once. Okay, include set for me. I'm going to say std set, again of integers, called duplicated data. That's good enough. So, as I said before, we should sort this data. How can we do that? Simple, using the sort function, which is a kind of, it's intro sort, which is kind of hybrid sorts, is among hybrid sorts. Include algorithm, std sort is in that library. Is from standard namespace, call me sort. Data from begin, it's a iterator, and I'm not going to teach C++. We are going to use what we have learned so far. This returns an iterator to the beginning of our vector. And I want to sort to the end of this vector. End. Okay. Now we have our data sorted. What we should do now? Compare each element with the next one. Let's do this. I want a for loop int I from 0 to I data.size and plus plus I if I don't want to go to the end of it, right? Going to data.size -1 is enough because I'm going to compare each element with the next one. So this next one, if I don't do that, it's going to be out of bound checking. We don't have any bound checking now, and it's going to be out of bound. So if data, the ith element of data is equal to I plus 1th element of that data, what should we do? It means that we have a duplicated element. So why this? I'm going to add it in my duplicated data. Dot. Does it have any append or add? Does it have add? Nope. Append. Let me see. Insert. Yeah, append is for Python's list. Insert data I. So that's it. We have our duplicated data in duplicated data set. And now I'm going to show that. I'm going to use a range-based for. So for int day duplicated in duplicated data, and I'm going to show that from a standard namespace, call cout and show duplicated. And at last, let me show a new line, end line. That's it. Let's start our program. C++, G++ test.cpp. It says that only 1, 2, and 3 are duplicated here. Let's see. 1, yes, it's duplicated. 2, yes. 3, yes. And 5, 6, and 10, they are not duplicated. Let me add a 10 at the beginning of my vector. Let's recompile that. That's it, yes? So this is going to be our first approach. I use the built-in sort function, which was an intro sort, O n log n. So this complexity for this approach was, it depends on the sort algorithm that we used. For example, again, in Python and Java, it's again O n log n, or it's linearitmic. But it's not that fast. C++ is faster, obviously. So what about the next approach? At the end, I'm going to use one of Linux commands to have performance measurement. Now, let's talk about the second approach. Again, we have some data. 1, 2, 1, 10, such a big 0. 2, 3, 1, let's say 4. I'm going to use unordered map, right? It's again a container in C++, which acts like dictionaries in Python, okay? I'm going to say how many ones do I have. For example, 1, 1, 2, 3. 2, 2. 10, I have just 1 in my data. And that's it. We have 1, 3. It acts like dictionaries. It maps the number of duplicated element to how many it duplicated. So I think it's obvious what we are going to do. But it has a problem. It takes almost roughly twice memory as the previous approach, but it takes a little less time. Around, it depends not to number of our data, but 4 or 5 seconds, but roughly 2 times memory, because it's obvious. We are mapping each element to number of occurrences. So let's implement this. Let's make a function for this. I don't want to write again this data. Void find the first approach. Which takes a vector of integers called data. And I'm going to copy paste this there. Now, let's talk about the second approach. Void second approach. which again takes this. And I should mention that we are going to just solve this. I'm going to talk about the design patterns. We are not talking about designs, because as Uncle Bob says in his clean code book, definitely it's not a good function, because I'm doing more than one thing in my function. He says that every function, every method that we have to just do one thing at a time. So please put that away. We are going just to solve that problem. I'm not talking about design patterns or how can we build a good system, just algorithm of solving that problem. Let's solve it. So I want unordered map include unordered map from std namespace. I want unordered map unordered map from an integer to an integer. My data is integer here. The previous approach had a problem. It just works for objects that can be sortable. If the object cannot be sorted, so we cannot use that much easily. std unordered map from an integer to an integer. Let's call it duplicated data. And that's it. Now, let's go from int I from 0 to I is less than data, that's size, plus I. Good enough. Now, if I have that data in my unordered map in my dictionary, so I should increment the number by 1. And if I don't have that, I should say that I have 1. So if what should we call it? Duplicated data that find data as is equal to duplicated data. That's end. It means that I don't have that data in my duplicated data map. Okay? It's how we say it in C++. It depends on your programming language. I don't want to talk about the programming language that we are using right now. We are talking about algorithms. We have something exactly like this in Python and Java. So in C++, we implement it like this. If duplicated data that find the ith element of data is equal to duplicated data that end, it means that we don't have that data in our duplicated data map. So duplicated data data I is going to be 1, right? Right. And else we should say something like this, +1. I hope this makes sense for you. It's easy, right? The simplest problem that we can solve for our first video. This is my first video that I'm recording. It should be good enough. Let's see what we did. We have duplicated data of unordered maps from an integer to an integer. We are going from 0 to the last element of our data. If it couldn't find the data in duplicated data, it means that we don't have it, so we assign 1, and else we are going to increment it by 1. And good enough, let's show it. Again, I'm going to use range base for showing that. Auto, let's call it I. It's not good naming. As I said before, we are just solving the problem, okay? In duplicated data, if I that second means value. We are using key values, right? I that second in C++ means value. If it's greater than 1, simple, std cout I dot first, right? If the value, key value, if the value is greater than 1, we should show the key, which is the element itself. The keys here are element itself, and values are number of occurrences. So if I dot second, which means number of occurrences, is greater than 1, we should show that value. And let's call this function. Second approach, data. Good enough. The same answer as we got there. 1, 2, 3, 10. 1, 3 to 1, 10. It's not important. Now, which one should we use? I should mention that if you don't want to use this, you could use built-in function called adjacent find in C++. I didn't use that. For those who don't know C++, can implement this easily. If you are using C++, you can use adjacent find instead of comparing each element with the next one in this approach. Okay. Now, we have two approaches. Which one should we use? That's the question to be asked. Let's increase the number of our data. Let me include, it doesn't need to be included. srand time 0. I'm going to generate 1 million data randomly to test which approach is better. srand times 0. I have a vector called data. For, let's say, const size t. Size t is something like integer, but in C++, if we want to allocate some size to a vector or something like that to containers, we use size t. It's not important. Assume that it is an integer. Const size t 1 million. Right? All right. For int, or again, it's better to use size t. Size ti from 0 to I less than number of data. Plus I. And say that data dot pushback rand. Rand function generates a random function, and I seed that random function with current time. It uses epoch time. They are not important, that I'm not mentioning them. They are not related to our problem. Just know that rand function generates random number from 0 to modulo, let's say 10,000, maybe. Yes. 100,000. It should be good enough. And this is 1 million, yes? Yes, 1 million. Now we are going to find duplicated data in 1 million array, in 1 million elements in an array. It's a really huge number. Not that big, but it's bigger than just 10 numbers. Let's first use our first approach. First approach, what's that? Data. And now we are going to measure this. How? With the power of Linux. Okay. Let me compile. For performance measurement, we have so many profilers, I think. The static analyzers. But I'm going, for example, the Valgrind. It's really big things, very big thing to use. I don't want to use that much of data. I'm simply going to use a Linux command. User bind time. If yes. Please, it is different from this. These two commands are not the same. Please be sure to use user bind time. They are two different commands or different programs. Now we compiled our program and that's it. Edit out. This command profiles our program. Let's run this. What happened? I didn't call this to run. It's going that much fast? Yeah, it looks like. This is the duplicated data which we randomly generated. All of this data is duplicated there. But I forgot to put verbose argument here. Let's say verbose. And as you can see, every element is duplicated. You know why? Because here we said modulo this number. I should say modulo number of data. It's obvious that all of our data was going to be duplicated. Again, test. It gets better. Now this number is duplicated. Here is not duplicated. This is duplicated, and so on. It takes about 1 second to run and 2300 of kilobytes of memory, right? And this is the performance measurement. Let's increase this number by 1. Let's say 10 million. It's a really big number, right? Let's see what will happen. It takes more time. Oh, what's good enough, yes? 11 seconds. You know, now you can see the power of C++. Just kidding. In 11 seconds, we sorted about 10 million data and then iterate over all of them and find the duplicated data. And it takes about 205,000 kilobytes. It's around 205 megabytes, right? This was our first approach. Please remember this. Seconds, 205 megabytes. Now let's use the second approach. Let's comment out our first approach and use the second. Compile this. It's going to be faster, about a second or two, but almost twice memory. Let's see what will happen. It takes roughly again 11 seconds and 409 kilobytes. It's obvious why it is twice as the second, as the previous approach, because in previous approach we just saved the duplicated data, but in this approach we are saving the number of occurrences too. When I first saw this number, I got really shocked. 409 megabytes. Is that really true? How can we be sure? Easy, right? We are in Linux. We have a command called htop, which measure performance and everything that we have in our Linux. I'm not going to touch my laptop to go to an idle state. As you see here, we have almost 3.03 gigabytes of our memory is full now, and it's in idle situation, right? 3.03. Let's run this again. Three point 3.2, 3.3, 3.4. The peak of that was 3.41, I think. As you can see, yes, the answer is yes. And again, it's come back to 3.03. The peak was 3.4, and it came back to 3.03. 400 megabytes of our memory get used. That's it. I think that should be good enough for our first video. I hope you enjoyed it. Please put comment for me if you want to do any other things. And that's it. I hope to see your faces again. Goodbye, everybody.